Here we're going to talk about area between two curves. So it's no longer between the x-axis and the function. It's going to be between two different functions. So let's think about this. I already know that if I want to find the area beneath f of x from a to b, whatever this function is, that's represented, so that area there is represented by the integral from a to b of f of x dx. Okay, so well, I'm going to move that. So we already know this. The definite integral represents the area between the curve and the x-axis. Well, what if I had another function, g of x? So if I put in another function here, let's say g of x is below f. If I wanted to find out the area between the two curves, which would be this area, if I wanted to find this green area, all I would have to do is find this area, which is the red, right? And then subtract off the area from the blue. So let me write that down. The green area equals, well, I have the integral from a to b of f of x. That gives me that total area. And then I'm subtracting off the area beneath it. So subtract the area beneath g of x from a to b g of x dx. However, this, I mean, that's it. We could do the lesson now. We're done, pretty much. But there's a formula between the two curves. You can just combine these integrals, right? We have the same limits of integration, and we're both integrating with respect to x, so we can combine these two integrals. If I have, from a to b of f of x minus g of x dx, where f of x is the larger function, meaning the thing that's most positive, and g of x is a smaller function, so it's going to be bigger minus smaller. That hopefully should make sense, otherwise you'll get a negative area. So area between two functions is represented by that. And it's just that simple. I'm going to do an example now. Well, I mean, in a little bit. So it's important that you get that right. I mean, if you get the larger one and the smaller one mixed up, you'll have your area will be the opposite sign. So should be positive, might be negative, or should be negative, might be positive, something like that. So let's see. This is like a formula that you hopefully just it makes sense, so you don't have to memorize it. You just remember it. But if not, yeah, memorize it, because this is how you do this. So let's take a look at an example. So we have this problem here. We got this right here. We have to find the area between all of this stuff. Oh my goodness, what the heck? I don't even know what's going on. I don't know. So the first thing that I would do is graph these. It would be helpful to know what these graphs look like. If you ever are like on a test, you don't know what the curve looks like, you can always plot points. Yeah. Or you could use the graphing calculator, but if you can't use it on the test, then you'll just have to know the graph or plot points. In this, I know the graphs. What if you don't, though? Why am I trying to plot these anyway? Well, I do have to know which function is larger and which function is smaller. So, yeah, let's see what this graph looks like. I'm gonna just draw my. I don't even have to graph them that accurately. I just need to figure out what the graph is. So this one, either from a graphing calculator or plotting in points. Plugging in points. This graph looks something like this. It's like the 1 over x function, except for it's squared, so it looks like that. And there's an asymptote here. So, yeah, that's interesting. Yeah, there's an asymptote there. And y equals -4. That's easy. So this was in red. This one will be in green. y equals negative 4. 1, 2, 3, 4. I missed. So there we go. I have these two functions. Oh, and then this is a vertical line. I'll do that in black. X equals negative 4. Let's call that negative 4. So from there till negative 2. So I'm getting this area. That's okay. So the bigger function is this one. The smaller function is y equals negative 4. So I will just use this formula. Let's take our rook. So we have just the integral from negative 4 to negative 2. And I'm just doing this. 3x squared. No, 3 over x squared. Minus the smaller function. Well, the smaller function is just negative 4. So there's my integral, and this hopefully is easy. 3 over x squared plus 4 dx. Change the x squared so that it has a negative exponent. From negative 4 to 2 of 3 times x to the negative 2 plus 4, get the antiderivative, and then evaluate. So the antiderivative here would be negative 1. I'm adding, and then I make that negative, right? Dividing by negative 1, but it's just multiplying the same in this case. And then we have plus 4x. I evaluated from just negative 4 to 2. And what's that? Well, I'm plugging in 2 first, and I just get negative 3 over 2. And then it's plus 8, okay, minus, and then I just plug in the negative 4, so I that's negative 3 over negative 4, that's okay, and then I have plus negative 16, is that right? That's right, and then I distribute the negative there, so I get, I'm going to get a common denominator. This will be negative 6 over 4 plus 8 minus 3 over 4 plus 16. Okay. And then I have these two adding up. What is that? 9? Negative 9 over 4 plus 24. Whatever that is. I think I messed up somewhere. What did I do? Oh, it's a negative 2. There we go. So, ignore all of that stuff. That should have been a negative 2. I just dropped it way back there. Oops. So, the antiderivative is fine. Now, just this part. So, what is that? That would be negative 3 over negative 2 minus 8 minus plug in the negative 4, so I get negative 3 over negative 4 minus 16. Okay, so that should be different. That turns out to be 35 over 4, which is 8.75 if you're using a calculator. 8.75. Okay, that's better. Okay, I'm going to do another example in a different video.